Good afternoon to each and everyone, my dear students. So for today, we are going to discuss and present to you some examples of the fourth periodical examination on intermediate algebra. So this is for grade 8 who are taking up intermediate algebra, particularly in the spatial science curriculum. So let's start. So for number 1, the problem is this: which of the following is the common difference in the sequence -7, -4, -1, +2, 5, and so forth? So since this is all about arithmetic sequence, so we're going to subtract the second term minus the first term to get the common difference. So we have A2 minus A1 is equal to D, which stands for the common difference. And A2 is equal to 4 minus -7, which is our first term. Then it will become -4 plus 7, because negative minus a negative, it will become a positive. And if you're going to add -4 plus 7, so therefore the answer is letter D, which is equivalent to 3. Okay, so for number 2, which of the following which of the missing term in the arithmetic sequence 23, 18, 13, 8, 3, blank, -7, -12. So we're looking for the missing term. So there are several ways on how to get this one. But this time we're going to take up the most easy one. So the solution that we're going to take is simply getting the common difference of the second minus the first. So therefore, that is 13 minus 18. It is equal to -5. Then, adding this one to the term preceded by the blank one. So that is 3 plus -5. So therefore, the answer is -2. Okay, so the answer for this number is negative. For number 3, which of the following is the common difference in the sequence 3, -2, -7, and so on? So once again, we are going to use the formula second term minus the first term to get the common difference D. So that is equivalent to -2 minus 3 is equal to D. And -2 minus 3. So we're going to add and carry the common sign negative. So therefore, it is equivalent to -5. Okay, so that is -5. For number 4, which of the following is the common difference in the sequence 0, 4, 8, 12, and so forth? So again, the same formula is to be used. So the second term is 4 minus 0. So therefore, the common difference is 4. For this problem, you simply analyze the given phrases. So the question is this: which of the following describes an arithmetic sequence? A sequence in which a term is formed by adding any number to the preceding term. A sequence in which there is an equal difference between consecutive terms. A sequence in which a term minus the preceding term is always positive. And letter D, a sequence in which term follows a pattern. So there are some tricky situations here. However, there is only one correct answer, and that is letter B, a sequence in which there is an equal difference between consecutive terms. Next, which of the arithmetic sequence 2, 6, 10, and so forth up to 102 is 102? Or what term in the arithmetic sequence 2, 6, 10 is 102? So we have, is it letter A, 20th term, letter B, 26th term, letter C, 30th term, and letter D, 35th term. So to solve this one, we are going to use the formula a to the n is equal to the first term a1 plus n minus 1 multiplied by the common difference. But we need to collect first what is given in the problem. So our first term, or a1, is equal to negative 2, and our a to the n is 102. And the common difference, so we're going to take 2 and 6. So that is second term minus the first term. 6 minus 2 is equivalent to 4. And then, to solve for n, we have this one. So our a to the n is 102. It is given there. And the first term is 2. Plus, since we're looking for n, so that is n minus 1, and we are given that the common difference is 4. And then by distributive property, we are going to multiply 4 by n minus 1. So that is 4n minus 4, and then plus 2. We just bring down 102, and then we are going to subtract 2 minus 4, so that is equivalent to 4n minus 2. And then transposing negative 2 to the right, so it will be left, I should say. So that is 102 plus 2 is equivalent to 4n. Adding the left side, so we have 104 is equal to 4n. Then dividing by both sides by 4, so we have n is equivalent to 26. So therefore, the correct answer is the 26th term, which is letter B. And for the next problem is, we have this one. If three arithmetic means are inserted between negative 15 and negative 9, find the first of this arithmetic mean. Is it letter A, 3, letter B, negative 3, C, negative 6, or letter D, negative 9? So first, we're going to write the given. Since we have three arithmetic mean to be inserted between 15 and 9, so we're going to write this way. So that is 15 blank, 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 and then 9. And for the most easy way to solve this one, so we can immediately solve for D, so that if we are now if we know already the common difference, so we simply add to the first term and the succeeding term to get the terms in between negative 15 and positive 9. So using the formula, the last term minus the given term, negative 15. And you're going to count the number of terms here. And that is 1, 2, 3, 4, 5. So divided by the last term is the fifth term, and the given term before that is 1. So that is 5 minus 1. So if we're going to simplify this one, 9 minus negative 15, that is positive 24. And then 5 minus 1 is equivalent to 4. So that is 24 divided by 4. It is equivalent to 6. And then we are going to add this value to the first term. So that is negative 15 plus 6, that is negative 9. And negative 9 plus 6, that is negative 3. And negative 3 plus 6, we have positive 3. Positive 3 plus 6, so we have 9. Since what is being asked here is find the first of this term in that arithmetic mean, so therefore our answer is negative 9. Okay, so that is equivalent to negative 9. So let's proceed to the next problem. The next problem is this. Find the 21st term of the arithmetic sequence 6, 9, 12, and 15. So the choices are letter A, 61, letter B, 60, letter C, 62, or letter D, 66. So first and foremost, we're going to identify what is given in the problem. So we are not going to solve A1 anymore because it is already implied in the problem. And the common difference, we simply get the difference of the second and first. So that is 9 minus 6. So that is positive 3. So this must be positive 3, my dear students. And we are looking for the 21st term. So therefore, uh, that n is equivalent to n. It's equivalent to 21. And we're going to solve for a to the n, or that is a to the 21. So using the formula or the n term of an arithmetic sequence, so we have a to the n is equal to the first term plus the quantity n minus 1 multiplied by the common difference. So from the given, we have a to the 21. Okay, so we have here a to the 21 and the first term is 6. And the value of n, it is implied in the problem that we are looking for, the 21st term. So we are going to replace n by 21 minus 1, and the common difference is 3. I've said a while back that this is positive. That's wrong. So may you just correct it. And then that is equivalent to 6 plus 21 minus 1 is 20 times 3. And 20 times 3, that is equivalent to 60. And 60 plus 6 is equivalent to 66. So therefore, the 21st term of the sequence or the arithmetic sequence 6, 9, 12, 15, and so forth is equivalent to 66. So therefore, the answer is letter D. So let's proceed to the next. If three arithmetic means are inserted between 8 and 16, find the second arithmetic mean. So again, we are going to write the problem this way. Since we are given that the two extremes are 8 and 16, and we are asked to insert three arithmetic mean. So therefore, it looks like this. 8 blank, 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 and then 16. So again, to find or to get the next term, we simply get the common difference. So that is 16, or the last term, minus the given term before that. So that is 16 minus 8. And this is our first term, 1, 2, 3, 4, 5. So that is 5 minus 1, because this is considered as our first term. So that is 16 minus 8 is 8, and 5 minus 1 is also 4. And then get the quotient, 8 divided by 4 equals 2. And then after getting the common difference, we simply add to the given illustration above. So that is 8, the first term, plus the common difference. So therefore, the second term is 10. And then adding to again, that is 12. And then adding to again, that is 14. Adding to again, that is 16. And we are required for the second arithmetic mean. So therefore, the answer is 12. Yes, letter D is the correct answer. So let's proceed to the next. The problem is this: which of the arithmetic means or arithmetic sequence 93, 73, 53, and so forth is negative 27? So we are asked, or we are required to find what term is negative 27. So to find that, of course, we're going to identify what is given in the problem. So A1 is 93, not 3. Okay, and the common difference is negative 20. And we're looking for the n term, so n is unknown. And for our given term, a to the n is equal to negative 27. So let me check, my dear students. This is this is the first term is 93, not 3. I'm sorry, I was not able to write 9. And then after identifying what is given in the problem, then we are going to replace in the nth term of an arithmetic sequence, which is a to the n is equal to the first term plus the quantity n minus 1 multiplied by the common difference. So our a to the n is negative 27. It is implied in the problem. And the first term is 93. So that's it, 93. And we are looking for n. So we simply just write n minus 1. And the common difference is 20. How did we get that? So simply subtract this one, or 53 minus 73. So we can still get the same answer, that is negative 20. And then simplifying further, so that this negative 27 is equivalent to 93 plus, you distribute negative 20 inside the parentheses, so that is negative 20, and then negative 20 times negative 1, that is positive 20. It's equivalent to negative 27. Then we're going to add 93 plus 20, that is 113. And then, wow, there's a problem. This must be 113 plus negative 20. Yes, negative, that is 113 minus negative 20n. And then we're going to transpose negative 113 to the other side. So we're going to change the sign, so that is equivalent to negative 27 minus 113 is equivalent to negative 20n. We just bring down this one. Then solving now for the value of n, we divide both sides by negative 20. So therefore the value of n is 7. So therefore the correct answer is letter C. That is the seventh term. Okay, so let's proceed to the next. What is the arithmetic mean between 10 and 24? If we are given this kind of problem, so we are just simply getting the arithmetic mean. I need to say there is only one unknown or blank in between 10 and 24. So we can do that in this way. We simply add the 2 and then divide by 2. So that is 10 plus 24. The sum is 27, and then divided by positive 2. So 34 divided by 2 is, that is 17. So therefore, the answer is letter D. That is equivalent to 17. Okay, so let's proceed to the next. What is the 10th term of the following arithmetic sequence? Negative 5, negative 1, negative 3, positive 7, and so forth. I think it is just similar to the previous problem, so I will leave you this as your uh, sit work or homework. Okay, so in this problem, insert two arithmetic means between square root of 2 and 4 square root of 2. Which of the following is the first arithmetic mean? So you need to say we're going to insert 2 arithmetic mean between square root of 2 and 4 square root of 2. So we're going to write it this way. Square root of 2 and then blank, comma 4 square root of 2. So the same way we're going to find for the value of D. In the last term is 4 square root of 2 minus the first, that is square root of 2 all over 4 minus 1. Why 4? Because this is 1, 2, 3, 4. So this is the fourth term and that is the first term. So we're going to divide it by 4 minus 1. So 4 square root of 2 minus square root of 2, that is 3 square root of 2 all over 4 minus 1 is square root of 3. And then we can now cancel 3 because 3 divided by 3 is equivalent to 1. And then multiply that by square root of 2, so the answer is square root of 2. So from there, we are going to add square root of 2 from the first term. So that is square root of 2 plus the square root of 2. It is equivalent to 2 square root of 2, and adding again square root of 2, that is 3 plus square root of 2. Hence, the question required us to get the first arithmetic mean. So therefore, the answer is 2 square root of 2. And that is letter B is the correct answer. Then, for the next problem, we have the first term is negative 4 and the 25th term is equivalent to negative 100. And we are asked to find for the 100th term. So what is the 100th term? This given problem. Okay, so again, we are going to solve first for the common difference because we will be needing that in order to find the 100th term. So we have here the given is A25, that is negative 100, minus A1, or the term before 100, so that is negative 4, minus negative 4. Since this is the 25th term, so we divide it by 25 minus the first term. The number of that is 1, and this is 25, so that is 25 minus 1. And then negative 100 minus negative 4 is equivalent to negative 96. Because we are going to add this one or simply multiply this one, so it will become positive. Okay, so that is 25 minus 1 is 24. Then dividing negative 96 by 24, the answer is negative 4. So after having now your common difference, we are going to replace that in the nth term of an arithmetic sequence. So that is a to the n, and we have the 100th term minus the first term. This one, the first term. And the formula is n minus 1, so that is equivalent to 99. 100 minus 1 is 99, and the common difference is 4. Then multiplying this one, negative 4 times 99 is equivalent to negative 396, bring down negative 4. Since we have both negatives, so we'll add their absolute value, so therefore the answer is negative 400. And the answer is letter D. Okay, so next problem. If A is equal to 8, A third term, A sub 3 is equivalent to 8, and A sub 16 is equivalent to 47, and 8k is the kth term of the sequence, and A sub k is equal to 212, then what is the value of k? Okay, so how can we solve this problem? Again, the first thing to do is to find the common difference. So the last term given is a sub 16, and the first given is a sub 3. So that is 47 minus 8 minus their given term. This a to the 16 is 47, so the value of n is 16. A to the 3 is 8, so the value of k is 3. So that is 47 minus 8 is equivalent to 39. Then 16 minus 3, that is 13. Then 39 divided by 13. So the common difference is 3. So from there, we can now solve for the value of k. Since we are submitting the value of a1, so we are going to utilize a sub 3 from the given. So to find for a sub 3, that is equivalent to a sub 1 plus twice the common difference. And we are given that 8 is the third term, a1 is unknown, so we just let it to be a1 multiplied by 2 times the common difference, 3. There, we get a while back that the value of d is 3, so we are going to replace here. So that is 2 times 3 is 6. And then we are going to use addition property of equality on both sides. So we have 8 minus 6. And 8 minus 6 is equivalent to 2. And that is our first term. So we can now solve for k. So to solve for k, so that's it. I will remove first this one. So that is a sub k is equivalent to the first term plus k minus 1 multiplied by d. We simply replaced n by k because what is being asked is we are going to find for the value of k. And that is ak is 212, and then our first term is 2 we have here, and we are looking for k, so you simply copy that one multiplied by our common difference that we get a while back, that is 3, and then we're going to distribute this one. So we get 212 is equivalent to 2 plus 3k minus 3. And then adding positive to a negative 3, we have negative 1. And then we're going to apply again addition property of equality here. So we are going to transpose this one to the other side. So it will become 213 divided by 3k. And then dividing both sides by 3. So therefore the value of k is 71. So the correct answer is letter B. Let's proceed to the next. Insert 2 arithmetic mean between 3 and 30. So we have the same problem in this case, and I will let you this as your assignment. By the way, the answer is letter C. Okay, so for this problem, the sum of the first 12 term of the arithmetic sequence is 606. What is the first term and if the last term is 67? So to easily solve this one, again, we are going to identify what is given in the problem. So our n, we are looking for n, that is the 12th term, first 12th term, sum of the first 12th term. And the sum is 606. And our last term is 67, but we don't have the first term. So that's why I let it to be blank. And then using the formula, since we are now given 4, we are going to solve for the sum of the first 12 term, but we are not given the value of A1, so we are going to solve first for the value of A1. So I use here the short formula on finding the sum of an arithmetic sequence, which is equivalent to S sub n is equivalent to n over 2 multiplied by the first term plus the last term. And hence, we're given that the last term is 67. And to solve for A1, so we are going to replace in the given equation. So our sum of the 12 term is 606. Is equivalent to 12 divided by 36 and then multiplied by the quantity A1 plus 67. Now to eliminate 6, we're going to divide both sides by 6. So cancel 6 and then 606 divided by 6, that is 101. It's equivalent to the first term plus 67. And then by addition property of equality, we're going to move or we're going to remove 67 to the right side. So we're going to subtract negative 67 on both sides. So that is 101 minus 67 and 67 minus 67. That's why what is left is a of 1. And 101 minus 67 is equivalent to 34. So therefore, the first term is 34. Now, the correct answer then is letter C. Next problem. Because the second term of an arithmetic sequence is negative 16 and the eighth term is negative 8. What is the sum of the first 10 terms? Okay, so again, we're going to solve for D using the given. The eighth term is 8 and the second term is negative 16, so that is equivalent to 8 minus negative 16. And then since the number of terms here is 8, and that is the second term also. Negative 16 is 2, the second term, so that is 8 minus 2. Simplifying, so we have 24 divided by 6. And then 24 divided by 6, that is equivalent to 4. And then we're going to solve for the first term. How do we solve for the first terms? Of course, we are going to subtract negative 4 from the second term. And our second term is 16 minus the common difference, which is negative 4. So therefore, the first term is negative 20. So we are now ready to get the sum of the first 10 term. And using the formula, to find for the 10th term, so we have there the first term, negative 20. And n minus 9, that's why we have 9 here. And the common difference is 4. So that is 9 times 4, equivalent to 36. And then adding this one, so the answer is 16. So therefore, what is the sum of the first term? We replace now using the short formula in finding the sum of an arithmetic series. That is n over 2 times the first term plus the last term. So we are already solved for the last term, which is the 10th term. and that is equivalent to 16, so that is negative 4 multiplied by 5, so the answer is negative 20. So therefore, the correct answer is letter B, negative 20. So let's continue our review. I was not able to continue a while back because I'm school at this afternoon and it's already 5 o'clock. So I can't do anything otherwise but to go home. I'm now at home and then of course I've already set up my laptop and then continue my recording for the review of this lesson. So in this slide we have find the sum of the first 40 terms of the arithmetic sequence if the first term is 16 and the 10th term is 70. So first, we're going to find again the, the value of D or the common difference. How do we do that? So we're going to subtract the 10th term minus the first term. So that is 70 minus 16 all over by the number of these terms. So this is for the 10th term and this is for the first term. So that is 10 minus 1. Then simplifying, we have 54 divided by 9 and that is equivalent to 54. And then next is we're going to find now the sum of the first 40 terms in an arithmetic sequence. So we're going to use the long formula that is equivalent to n over 40. Our n is 40, so divide by 2. Multiplied by twice the first term. Our first term is 16. It is implied in the problem. Plus n minus 1 multiplied by the common difference. So our n is 42, so less 1. So we have now 39. And the value of d is 6. Simplifying, 2 times 16, that is 32, and 39 times 6, that is 234. Then 40 divided by 2, that is 20. We're going to add this one, that is 266 multiplied by 20. So the sum of the first 40 terms in this given problem, therefore, is 5,320. Yes, that is the correct answer. Next problem. Find the sum of the first 15 terms of the arithmetic sequence whose nth term is base of n is equal to 5 plus 3 minus n. So, solving for the first term, we simply substitute n or 1 for n, and that is 5 plus 3 times 1, and 3 times 1 equals 3. 5 plus 3 is 8. So this is our first term. And for the 15th term, since we are looking for the sum of the first 15 terms, so we want to find the value. So that is a sub 10 is equivalent to 3, or rather 5 rather, plus 3 times 15, the value of n. So 3 times 5 is 45, plus 5, that is 50. So we now have the first and last term. So since we have the first and last term, so we're going to use the formula n over 2 multiplied by the first term plus the last term, which is already given here before. That is 8 and 50. So substituting there, the first term is 8 and the last term is 50. So that is, the sum is 58 divided by 2. We have 29 times 15. So that is 433. So therefore, the answer 435 I should say. So the answer is letter C. Yes, letter C. Let's proceed to the next problem. Which of the following is the common difference in the arithmetic sequence 3, 13 over 4, 7 over 2, 15 over 4, and so on. So again, we want to find for the common difference. So that is second term minus the first term. And our second term is 13 over 4 minus the first term, we have 3. So we're going to subtract that one. We simply multiply 4 times 3 and then get the difference, 13 minus 12. So that is 1 over the common denominator. So therefore, the common difference is 4, and that is letter A. Very good. So let's proceed now to the next problem. Which of the following is an arithmetic sequence? Is it A, 1, 2, 3, 5, 7, 9? Letter B, 1, 10, 20, 30. Letter C, 1, negative 1, negative 3, negative 5, and so on. Or letter D, 7, negative 7, 7, negative 7, and so on. Okay, so since in the properties of an arithmetic sequence, if the difference of two consecutive terms are equal, then we can say that the sequence is arithmetic. So A2 minus A1 is equal to A3 minus A2. So what is A2 in letter C? So we have negative 1 minus 1 is equal to A3, that is negative 3 minus the second term, negative 1. Then simplifying, we add this one, that is negative 2, and we have negative 3 plus 1 because negative times negative, that is positive. Then, of course, that is, we simply bring it down, negative 2, and then adding this one, negative 3 plus 1, that is negative 2. Hence, A2 minus A1 and A3 minus A2 are equal. So, therefore, the correct answer is letter C. Yes, letter C. We'll proceed now to number 4. Which term of the arithmetic sequence 7, 10, 13, 16 is 304? So again, we are going to identify what is given. So that is A1 is 7. The common difference is 3. That is 10 minus 7. And we are looking for the value of n that correspond to 304. And the n term or the last term is 304. Then, by using the formula, a to the n is equivalent to first term plus n minus 1 multiplied by d. Our a to the n is 304 and the first term is 7. Then, since we are looking for n, so we just bring it down, n minus 1 multiplied by the common difference is 3. And then, we distribute this one, so that is 3n minus 3. Then, plus 7 is equal to 304. And solving now for n, so we use the addition property of equality. We less negative, we less 4 on both sides. So we have 300 is equal to 3n. And dividing both sides by 3, so the value of n is 100. So therefore, the correct answer is letter B. Okay. So we have here letter B as the answer. So for this slide, the problems state that find the nth term of the arithmetic sequence given the following condition. The first term is 2, the common difference is 3, and the value of n is 9. Okay, so we are going to substitute directly to the given problem. So we have a to the n, our first term is 2, and then our n is 9 minus 1 multiplied by the common difference 3. And then we replace and simplify. 9 minus 1 is 8 multiplied by 3, that is 24. And then plus 2. So therefore the correct answer is letter A. The answer is 26. Let's proceed to the next. Which term of the arithmetic sequence 2, 6, 10 is 102? Okay, we are going to find what term or what is the value of n or the term corresponding to 102. So again, my dear friend, to identify what is given, the first term is 2, there. The n term is 102, and the common difference is 4. How do we find that? We simply subtract 6 minus 2, that is 4. And we want to find what number, what term correspond to 102. And again, from the formula of an arithmetic sequence, a to the n is equal to first term plus n minus 1 multiplied by d. And we simply replace accordingly. So a to the n is 102. First term is 2. Then n minus 1 multiplied by the common difference 4. Then we are going to distribute 4 inside the parentheses. So we have 4n minus 2. And then getting the sum of 2 and negative 4, that is negative 2. Then bring down n. Then using again the addition property of equality, we add positive 2 on both sides. So that is 102 plus 2 is equivalent to 4n. And then finally solving for n, so 104 divided by 4, that is equivalent to 26. So the correct answer again is letter B. Next problem. Find the 21st term of the arithmetic sequence 6, 9, 12, and 15. So to find that, we identify again the given. A1 is 6, there. And then the common difference, that is 9 minus 6 is 3. And then we are asked to find for the 21st term, so n is 21. And we're looking for the value of a is of 21. So the solution is this. We're going to use the n term of an arithmetic series or arithmetic sequence, as we say. So that is a to the n plus the first term multiplied by n minus 1 times the common difference. Since we have n minus 1 and the value of n is 21, so we have 20 there multiplied by the common difference 60. Then 60 plus 6, that is equivalent to 66. And the correct answer, of course, is letter D. Now, the problem is, what operation is used in obtaining the next term in a geometric sequence? Addition? No, this is not the correct answer. Letter B, multiplication. Letter C, division. Letter D, subtraction. Since to find the next term in the geometric sequence is to simply multiply the common ratio to get the following terms. So therefore, the correct answer is multiplication, and that is letter B. Next, what operation is used in obtaining the succeeding term in an arithmetic sequence? Addition, multiplication, division, or subtraction? Of course, the answer is letter A. In order to find the next term in an arithmetic sequence, we are going to add the common difference. So therefore, the answer is letter A. Next slide. Which of the following term is closely related to a geometric sequence? So what term is being encountered in a geometric sequence? Is it A, common ratio? Letter B, common difference? Letter C, both A and B? Or D, none of the above? Of course, in geometric sequence, common ratio is there, or the value of R. So therefore, the correct answer is letter A. Next, which of the following term is closely associated to an arithmetic sequence? Common ratio, common difference, both A and B, or none of this? So this time, in an arithmetic sequence, we don't have common ratio. So it could not be A and B. And of course, since we have common difference, so therefore, option D is not the correct answer. So there's no other choice. The correct answer is letter B. There, the common difference. Next problem. If the first n term of the arithmetic sequence 24, 20, 16 are added, how many of these terms will be added to get the sum of negative 60? Okay, so the answer is, first of all, we're going to identify the given. A1 is 24. There, the common difference is, of course, negative 4. That is 20 minus 24 is negative 4. And we are asked to find what term that will give us the sum of negative 60. So, from the given, we are going to use now the formula S of n, or the sum of n is equivalent to n over 2 multiplied by twice of a plus n minus 1 multiplied by the common difference. So, S of n is 60 there. And then the value of n is, there's no value of n, by the way. And then the first term is 24, it's already given. And the common difference is 4. So we'll simply bring it down n minus 2. And then by FOIL method, we're going to distribute negative 4 inside. So that is n times negative 4 is 4n. Then negative 1 times negative 4 is positive 4. And then simplifying it further, so we have negative 120 is equivalent to n multiplied by 52. Or did we get 52? That is 48 plus 4. And then we have there negative 4. And then equating to 0, using addition property of equality, we are going to move negative 4 and square to the right. So that is positive. The same true with 52n. We move it to the right of the equal sign. And then we also move. So therefore, the answer is n minus 10, n minus 3 is equal to 0. And then equating both factors. So n minus 1 is equal to 0. And n minus 3 is equal to 0. Solving for n is equal to 10, or n multiplied by 3. Since if we're going to replace n by 3, so we don't have negative 60. However, if we're going to substitute n by 10, and let's extend this one, so the correct answer is n is equal to 10. And that is letter A. Wow, it's correct. So let's proceed to the next problem. Yaya received a starting salary, annual salary of 60,000 with a yearly increase of 3,600. What is her total income for 5 years? So identify again what is given. So we have A1, 60,000. Common difference is 3,600. And the value of n is 5 because we're looking for the total salary she will receive after 5 years. So that is 5. And we're looking for her salary for 5 years. And then using the formula, S of n is equivalent to n over 2 multiplied by twice of a plus n minus 1 multiplied by the common difference. So our n is 5 divided by 2, and the value of a is 60,000. And then we have there, the value of n is 5 minus 1, so that is now 4 multiplied by the common difference, 3,600. Simplifying, so we have 5 over 2, we bring it down. And then 2 times 60,000, that is 120,000. 5 minus 1, that is 4. And then we bring down 3,600. So adding the 2 after multiplying 4 times 3,600, that is 14,400 plus 120,000 multiplied by 5 over 2, that is equivalent to 134,400 multiplied by 5 over 2, and then we are going to divide 134,400 by 2. So that is 67,200 times 5. So the correct answer is 336,000. And that is, of course, letter D is the correct answer. Okay, for this problem, is it the sum of the terms? It is the sum of the terms of a sequence. Is it mean? Is it sequence? Is it nth term or series? Of course, when we say series, we are referring to the sum of the terms of a sequence. So therefore, the correct answer is letter D, series. Next. Okay, what operation is used in obtaining the next term in a geometric sequence? Of course, that is multiplication. Letter B is the correct answer. Next. What operation is used in obtaining the succeeding term in arithmetic? That is letter A, addition. Okay. Next, which of the following terms is closely associated to an arithmetic sequence? Of course, letter B, common difference. Is the correct answer. Okay, the common ratio of a geometric sequence is 1/2, and the fourth term is 1/4. What is the third term of the sequence? Okay, so the formula for the nth term of geometric sequence is equivalent to a to the n equals raised of 1 times r raised to n minus 1. And in the given problem, r is equivalent to 1/2, and the fourth term is 1/4. So we need to find first the value of a1. So we replace from the given formula a to the 4 is equivalent to a1 multiply the value of r, and then your value of n is 4 minus 1. Then we simplify and then divide. So that is 1/8 divided by 1/8 on both sides. So therefore, the correct answer is 2 for the value of a1. Now, we can now find for the third term. So, substituting now in the formula, a to the n is equivalent to the first term multiplied by the common ratio raised to n minus 1. So, the r is 1/2 and the first term is 2. And then, why 2? Because we subtract 1 from 3. Since our n is 3. So, minus 1. That's why we have 2. So, 1/2 raised to 2, that is 1/4 multiplied by 2. That is equivalent to 2 over 4. Then, reducing it to lowest term. So, we have 1/2. So, therefore, the third term and the correct answer is letter B. Okay. So, next. So, what expression is same as A times A multiplied by B times B? So, the principle we're going to use here is the sum or product of exponent with the same base. So by that property, if an exponential expression having the same base, then we simply add the exponent and copy the common base. So we have x raised to m multiplied by x raised to n, copy the common base x, and then add the exponent m plus n. Applying from the problem, so we have a 1 plus 1 plus 1 plus 1. We added the exponent of these terms multiplied by the common base also b, and then adding also the exponent. So we have a to the 4 times b raised to 2. So therefore, the answer is letter B. Okay, next. So this time, since I have already introduced to you similar problems on this problem up to the last one, so I'll be leaving you as your assignment for the solution of this problem. By the way, if you're going to scan or continue it, the correct answer is already given, but what is provided for you is to simply give the correct answer. So in this, a whole has a 30 rows. Each successive rows contains one additional seat. The first row has 25 seats. How many seats are in all in the hall? And the correct answer is letter A. That is 1,185. For the next problem, Mrs. De La Cruz started her business with an income of 125,000 pesos for the first year and an increase of 5,000 yearly. How much is the total income of Mrs. De La Cruz for 8 years since she started her business? So I will just showing you the answer. That is letter C, but for the solution is left for you to do. That is equivalent to 1,000,000 1,140,000 pesos. For the next problem, Mirasol saved 10 pesos on the first day of January, 12 pesos on the second day, 14 pesos on the third day, and so on, up to the last day of the month. How much did Mirasol save at the end of the month? So again, this is a problem about sum of arithmetic series, but I did not provide you the solution, but I will be giving you the correct answer. That is letter C. It's equivalent to 1,240. Again, I will be giving you the authority or the privilege or authority to show the solution. The next problem, Jane was saving for a pair of shoes from her weekly allowance. She was able to save 10 pesos on the first week, 13 pesos on the second, 16 pesos on the third, and so on. If she continued saving in this pattern and made 52 deposits, how much did Jane save? Okay, the correct answer is letter C again, 4,498. Again, the solution is left for you to do. Again, this is live. Mary gets a starting monthly salary of 6,000 and an increase of 600 annually. How much income did she receive for the first 3 years? The correct answer is letter B. That is 237,600. Just as I've told you, once again, the solution is left for you to do.